Now in this lecture, we have to prove that integration of e to the power minus ax minus e to the power minus bx upon x under the limit 0 to infinity with respect to x, which is given by log b by a, where a and b both are positive numbers. Let I of a is equal to integration of e to the power minus ax minus e to the power minus bx upon x under the limit 0 to infinity with respect to x. Now, there are two parameters a and b, and x is the variable. So now it can be also solved by using by taking I of b. Now, but in both the cases, we will get the same answer. So I am using the I of a, which is equal to this. Someone can also take I of b. And if we go through the step by step, we get the same answer. Answer will not be changed. So let me take it I of a, which is given by integration of e to the power minus x minus e to the power minus bx upon x under the limit 0 to infinity with respect to x. Let us give it equation number 1. Now, using DUIS rule number 1. Why we are using rule number 1? Because the limit of the integration both are constant, 0 and infinity, both are free from a, so we use the differentiation under integral sign rule number 1. If we differentiate I of a with respect to a, it gives us dIdA, which is equal to integration under the limit 0 to infinity and partial derivative of e to the power minus ax minus e to the power minus bx upon x with respect to a whole dx. Now, here, if you want to find out the partial derivative of this term with respect to a, x and b will be constant. Only we have to take care of a. So now first we can take 1 upon x outside like that. Integration under the limit 0 to infinity, 1 upon x we have taken outside, and partial derivative of e to the power minus ax minus e to the power minus bx with respect to x. 1 upon x derivative of e to the power minus e to the power minus x, which is given as e to the power minus x, and derivative of minus x with respect to a is minus x, and minus derivative of e to the power minus bx with respect to a is 0. So here the derivative of e to the power minus x is minus x e to the power minus x, and derivative of e to the power minus bx is 0. Now this x and this x will cancel, and then there is a minus sign because this is only the minus sign. So minus of integration of e to the power minus x under the limit 0 to infinity with respect to x. So now if we integrate it, what is the integration of e to the power minus x? It is this minus sign, the minus of e to the power minus x upon minus a under the limit 0 to infinity. So this minus and this minus will become plus. It is 1 upon a. If we substitute the upper limit e to the power minus infinity, if we put the lower limit e to the power 0, which is equal to 1 upon a, 0 minus 1. So it is equal to minus 1 upon a. Hence, dIdA is equal to minus 1 upon a. Again, since it is a differential equation of variable separable form, so separating variables and integrating, we get integration of di, which is equal to minus of integration of 1 upon a with respect to a plus integrating constant, where c is integrating constant. Now, we know that what is the integration of di? It is nothing but I, and which is function of a. So we write down I of a, which is equal to minus derivative integration of 1 upon a is log of a. There is a minus sign, so minus log of a plus c. Let us give it equation number 2. Now we have to calculate the value of this integrating constant from equation number 1 and equation number 2. Putting a equal to b in equation number 2 and as well as 1. We have from equation number 1 I of b is equal to integration of e to the power minus bx minus e to the power minus bx upon x under the limit 0 to infinity. So e to the power minus bx minus e to the power minus bx, it gives us 0. So 0 upon x, which is equal to 0. So I of b is equal to 0. This is from equation number 1. And similarly, if you put a equal to b in the second equation, what will happen? From 2, I of b is equal to minus log b plus c. But I of b is equal to what? Its value is 0. So c is equal to log of b. Hence, if you put the value of 2c in equation number 2, we have I of a is equal to minus log of a plus log of b. But we know that log b minus log a is nothing but log b upon a. So therefore, I of a is equal to log b by a. Hence, integration of e to the power minus x minus e to the power minus bx upon x under the limit 0 to infinity with respect to x, which is given by log b by a. This is the desired result, hence proved. Thank you.